There's this question. I'm going to take a sip of my protein. How to develop Verilog code, can you please help? This is the same viewer, man. So if you're watching this and you're not subscribing, I don't know what you're saying. I don't know what you're doing. Yeah, let's just do this one. So let me copy this old one I just did as not overwrite it. What is this problem actually? How to develop Verilog code for this question? Write a dot that does this input I asserts only one clock cycle, so it's a pulse. After the input asserts, then the output should assert 5 cycles later, then the assert for another cycle. So 101. Basically, if another pulse on an input appears these 8 cycles, output 101 pattern should not be generated for this output. So basically, if during these strings of zeros and between these another input comes in as a 1, it should just get dropped. All right, so let me copy this description and okay, actually, do I get demonetized? Okay, I'm just gonna say weird handshake. All right, quite good here. All right, let's just erase this. My mouse ran out of battery in between the last video and this video, which to the viewer could be an indefinite amount of time. I literally recorded the last one and it just died on me, so quite lucky actually. Okay, so yeah, I guess one thing I didn't know, like after 5 cycles, is he saying like on the 5th cycle or like 5 cycles, you know? So I get it, and then 1, 2, 3, 4, 5, 6. Wait, this is 6 cycles later. So, or am I just blind? 1, 2, 3, 4, 5. So 6. Maybe that's why he's struggling with the problem, because it's 6 cycles later. What is this? 1, 2, 3, 4, 5. So if the 101 happens 5 cycles later, isn't the 101 supposed to be here? I guess this is just semantics, but he also says like there's an 8 cycle thing. So 1, 2, 3, 4, 5, 6, 7, 8. So it's not so basically I'm having with like a inclusive exclusive problem. Like he says if another pulse on input appears during these 8 cycles. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm assuming these 8 cycles because he can't be saying, well, another input occurs in the same cycle as the input, but then a 101 is 1, 2, 3, 4, 5, 6 cycles later, right? Because this is 6 cycle, 7 cycle, 8 cycles later, meaning here and onwards, I would, yeah, only here and onwards would I accept another input. So I feel like this is saying like 6 cycles later. It's not 5 cycles because 1 cycle later, 2, 3, 4. This is 5 cycles later and it's not asserted, right? Unless he means like, oh, I have a 1 pulse here. It's 5 cycles after it goes back to 0, but yeah, I don't know. And then I don't know why this module. So I would, if someone names something module 2 in an interview, I would not hire. Doesn't matter to get the problem right. Because like, yeah, I don't want to be reading, for example, cryptic puzzle. Like it's called code because it's confusing enough. Like it doesn't need to be more confusing, but I'm just gonna do the problem and shut up. So I'm just gonna call this module um, module what? Weird handshake, actually. And instead of input wire, I like logic. In the previous video, I kind of mentioned already why I like reset n better, but whatever. I like logic better than regs or wire. And the reason is because it's more maintainable. In that you're not going to just make like careless mistakes. Like why are you doing this extra work of like splitting hairs between wire and regs when Synopsys already can typecast it for you properly? Like it makes no sense. Like you're just wasting time if you're not doing like logic as opposed to reg or wire. That's how I feel about that. I want to put this in a separate line. So I like putting things that are related in the same line via commas, but I don't really like necessarily like no, there's a comma, right? I don't remember. Yeah. I don't really like just just because it's one bit signal, you just shove it on the same line. Like for me, for maintainability reasons and for ease of reading, like things are related, I would put input logic. Like for example, if there's an enable bit that qualifies this input, then I would put it on the same line. But if it's a separate piece of thing, I would put it on a separate line. It's just so that it's like more clear for me anyway. You can condense things that are similar in one line because the reader would just be able to mentally, conceptually just shove it all together. And then, if they're looking for something else, they'll just, their eyeballs would just glance at the next line. All right. So let's do this game where we see if it compiles. Instead of y, I did out because out is more, there's more meaning embedded in the word out as an output than just y. So I'm just going to go with that instead. So let's see if it compiles. So we're guaranteed this only asserts for a cycle. So that's good. I think the challenge would be here when we just say like 1, 0. We just have to make sure that I and the next cycle it must be 0. So so what I want to do here, so I kind of want to set a state bit where it's like handshake in progress. Kind of like in the previous video, I'm probably just going to set this and then clear it when the 101 is detected 8 cycles later. But since it's an 8 cycle thing, I almost don't care about the since 8 cycles later, it's the 101 pattern doesn't matter as much as like it's a fixed amount of cycles. So this is 6, 7, and 8 cycles after this 101. Okay. I know what I'll do actually. I'll do like a test vector where it's like it'll just be this, and then the output I'll just shift in the I, yeah, and then the output we can kind of shift in another like buffer just to make sure that everything's hunky dory. We can also count it from the output like we usually do. Yeah, I might just do that. I might not complicate things too much in this video because there's still a lot of practice problems for me to run through today. Handshake in progress is a state that I'll maintain as soon as this is asserted. And then what other things I need? I need to clear the handshake. And I just need to set handshake in progress. Okay. So this part is easy enough. This is just I. Right, and then let's just do this. So if I'm in reset, my handshake in progress status bit is going to be 0. Otherwise, if I'm setting handshake in progress, or handshake in progress and not clear handshake in progress, then I just want to do, so this statement says, all right, I'm handshaking. So actually, yeah, it's easier if I just do like this. So this says, hey, if I'm setting it, then, obviously the next cycle, I'm gonna have the handshake in progress. And if it's already in progress, I want to hold that status bit. And if I want to clear it, then just clear it. So this is just gonna be straight up hold on a second. Handshake in prog is handshake prog next flopped, right? Okay. So this is the state bit or the status bit maintenance flop. And then the other thing I want to do is like, well, let's actually set it. Then I need to start a counter to count how many cycles have elapsed since since this happened. And since we can go up to 1, 2, 3, 4, 5, 6, 7, 8, we will need 8 is what? 1, 0, 0, that's 4, and then 0 is 8. So that's 4 bits. And then this is the flops for output handshake. And let's take a drink each time. Say pretty sure you'll be dead at the end of the video if you took a shot. Maybe I should take like public speaking before I interview. But I'm also interviewing next week, so it's like that's the best I can do, pretty much. Anyway, where was I? Positive clock, positive reset. This is to, okay, yeah, the counters, right? So if I'm setting the handshake in progress, Okay, then the clock count needs to start incrementing. I wonder if I can just do this, actually. So if I'm inputting it like this happens, then the next cycle, this would be a 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. And on the 8th one, I believe, yeah. On the 8th one, I would clear it. Yeah. So I'm just trying to calculate if there's any combinational loops. So this is feeding into a gator, which is in the flop. If I do like, this is actually going to take the Q pin of this, so this is segregated from this. Okay, so I think we're good, hopefully. I want to clear this if it's 8. And yeah, also want to assign the output when the clock count is, 1, 2, 3, 4, 5, 6, or 7, 8. So if it's 6 or 8, then the output is 1, otherwise it's 0. And I need to take care of the last case, which is the intermittent inputs. So even a 1 here won't cause a 101 later down the road. But anyway, and so if I have another 1 like in the middle, what'll happen? Nothing. So let's say I have this 1 here, right? And then I do this set equals I. So this will be 1. But if I'm in the middle of this stream anyway, I'm already, my counter, like this is already a 1. Like it's been set. So this would just be counting all the way up until 8 until it clears. So the fastest, the key point here is like we don't want this input messing with this counter because our output is tied to the counter, right? So if it's already a 1 and you put another 1 in, the counter is just gonna basically drop it. And when the counter can only be oh actually yeah, so I actually need to reset this counter. So in the previous video, I mentioned something where the clear would take precedence, and this is one of those cases. And the reason is because, so for example, if you had a 1 here, you still don't want this 1 to be able to generate the 101, which means that on the 8th cycle, this clear is set to 1. But if the handshake is progress, this would be cleared. But if you have an input, and this without these parentheses, this 1 outside would keep this as a 1, which we don't want. So if we have a set and a clear at the same time, the clear would actually take the precedence. And yeah. And if declared takes precedence, that means this will go to 0. And if this is 0, that means the next cycle, it'll be 0 again. And in the next cycle, as this is 0, it can actually be able to set this to a 1 again, meaning on this cycle, it could be a 1 again. But we'll test those cases out. I just want to see what else I'm missing before I actually start writing a test for it. Okay. Let's just see if it compiles even. All right. So yeah, clock 0, reset 1, and we I want to see if there's a way to, I know there's a bit reversal thing. It's like a weird shifty, no. There's like a special syntax to reverse bits in a bus. But if I can't find it, then, oh. Yeah, I think this is it. Okay. This way, if I run a for loop, I don't have to do like MSB to LSB, like, because this is time order left to right, and if I run a for loop, it'll be from right to left, like LSB to MSB. So this just reverses the bit, so like I can just write a for loop easier. Okay. Actually, maybe yeah, I mean 10's enough. I can just change this vector to test a bunch of different cases. I is less than 10. I'll just do nothing for now. I just want to see if it compiles. Test vector is not defined. I want the input and output, obviously. I probably also want to know if the handshake in progress next. And I also want to know probably the clock count, just so I get a little bit more information. Okay, so at least it compiles. So since I do want this, maybe I just have the next cycle. Um, nah, let's just have it in this cycle. So I'll display it, and then I'll okay, and then so what I want to do is first I want to actually I think this blocking sounds good. And reset equals 0. And then I want to do okay, so this is just basically say do this 0 1 0 0 1 0 0 1, and I'm just going to be expecting this basically. I don't know why I was like hanging. What's up with that? Okay. What about like maybe this line's just doing something weird? Because there's no like infinite loops. Huh. Okay. What if I just don't do anything? And I did like I equals 1. Okay, so I mean like this doesn't kill anything. So what was causing that? You know, that's quite weird. Oh, yeah, if it reassigns to itself, it might do some weird things. Because both the I and the iterator I is the same variable. Fuck. So I guess the lesson here is this is a very bad interface. So if you're gonna do input and you don't want to have like input as a word, just say in or something, or do like handshake underscore input. Anyway, let's just see if if any of this worked. So, okay, the first input is oh, actually, I just want to double check what this looks like. So 0, 1, 0, 0, 0, 1, and 0, 0, 0, 1. So that's cool. And 1, 0, 1. So that's cool. 1, 2, 3, 4, 5, 6, 7, 8. So perhaps we actually need to make this a bit longer. 1, 2, 3, 4, 5, 6, 7, 8. So how many bits is this? So this is 21. 21. This is 20. Oof, syntax errors. All right, this is a long one. Why is this missing a 0 on the top? Oh, it's 22 bits, that's why. So another takeaway is like you need to know how to count and Okay, so that looks a bit better. This is the reverse of that. All right, cool. So, right, again, here we have like this 7, 8 thing, 6, 7, 8. And I just want to stress test this so that like 8 cycles later, like it's not gonna count this one, for example, and then output something 1, 2, 3, 4, 5, 6, 7, 8 cycles later. So instead, I send another one like a few cycles after this first handshake, and then now I should send the output 1, 0, 1 here, and I kind of stress tested because I sent 4 inputs here just to make sure that it's not interfering with anything. And in fact, if I were to do like this, should still yield the exact same result, and it does. So yeah, this was a long enough video, so I will just see you in the next one.